All right, great. Thank you so much. We're going to resume now so we can stay somewhat on time and get through this final session. We'd like to say all these things today have been fabulous, but in many ways we're saving the best to last, in that we're going to talk about these promising technologies that can be part of potentially some alternatives we explore in the feasibility study process. We're also going to talk about your ideas and ways for you to stay engaged. So these are really important sessions coming up. We want to make sure that you get all that in before the end of the day. So with no further ado, we're going to launch into the next panel, which is opportunities for naturally improving water quality. We have two presenters in this panel. I will mention that originally we had a third presenter, Kevin Morris, from the Peace River Manitoba Water Supply Authority, and he asked that I pass this along to you, so I'm going to share this just so you can keep his family in your thoughts and prayers. They unfortunately lost their only son recently. He was supposed to go on in the fall, got a scholarship to Yale, went down with a best friend to Peru, and on a motorbike they were hit by a bus and killed, both killed. And so he is going through unbelievable grief, and we are really thinking of him today and his family. And if you know him, please, reach out and let him know you care. I know they're just really struggling right now. So anyhow, we completely understand, and they had no other presenter who was able to come. So we are going forward with our two fabulous presenters, and I'll just let them first start by introducing them.
All these funny beeps. I'm Chris Keller. I'm the president and senior engineer with Wetland Solutions in Gainesville. I've been fortunate to work in South Florida environment here for a number of years on. There's the red button. There's no red button to hit.
Yeah, there is no red button to hit. Hold on a second. How about that?
Talk louder.
How about that?
Chris Keller with Wetland Solutions in Gainesville. I'm the president and senior engineer with that firm. We've been fortunate enough to work on a variety of South Florida treatment wetland-based projects over the last few years. My experience is at about 25 years total now, specializing in treatment wetlands.
And I'm David Lindsay. I'm the district manager for the Lehigh Acres Municipal Services Improvement District. We're going to look at some of our recent projects, current projects, and some future projects that may benefit the reservoir. We just happen to be the adjacent next door neighbor to the reservoir, so it worked out very well.
Right. So here you go. You can come up to the podium, whatever.
So I'm going to speak this afternoon for a few minutes just about constructed wetlands and their capacity to reduce nitrogen concentrations. I'm going to focus on a couple of projects in particular as I work through the presentation. I'll give a real brief background on treatment wetlands, what they are and how they work. I'll talk a little bit more specifically about the wetland nitrogen cycle and where those opportunities are to really reduce nitrogen concentrations and loads working through treatment wetland type projects. Talk about just three projects I'm going to highlight that have shown the ability to get down to very low total nitrogen concentrations, which is important and relevant for this particular watershed, and then wrap up with a couple of success as folks are planning these projects and thinking about their potential implementation throughout the watershed. Cool. That's not the way it looked last night. So there are a variety of different types of treatment wetlands. When you start to go out in the literature and look for these things, they range. There are natural treatment systems, which I'll show you a picture of in a moment, and then there's a bunch of different types of constructed treatment wetland systems. Within that category, there are two major branches. One are surface flow or free water surface treatment wetlands, and those are what you normally think of as a marsh. They're the type of system where you see exposed surface water, you see emergent plants coming up through that water. Water typically has a way in and a way out of those types of systems. The other major category of constructed treatment wetland systems are referred to as subsurface flow, and those are ones where the water surface is maintained below the top of the soil or substrate surface. Some have different applications or purposes. There are, within the subsurface flow variety, a whole bunch of different permutations of those and different ways you can move the flow through there horizontally, vertically, tidally, with a kind of a fill and drain type system. There are all types of intensified systems now that are being designed to really reduce the footprint, where oxygen is added to the system either through pumping air or applying a liquid oxygen feed to the system. There are other chemical supplements that are sometimes added that maybe make up for trace nutrients or elements that are missing that can some of the processes. Various types of media that can be used to provide additional absorption surfaces. So there's a whole a range of different types of projects out there. When we get into Florida in particular and start to look at what's been done, they really fall into these two categories. There are a lot of natural, or not a lot, but a dozen or so natural treatment wetland system projects where existing hardwood wetland communities that maybe have had some kind of hydrologic degradation over time could use supplemental water, have been used as a way to further polish municipal wastewaters or to, in some cases, treat stormwater. What most of the constructed wetland projects are in Florida, and this represents certainly the STAs that the South Florida Water Management District has constructed south of the lake, are these constructed surface flow marshes. Within those marshes, which, as I said, make up most of the types of systems that have been constructed in Florida, we talk about different plant communities. You've heard reference to most of these today. Floating aquatic plants, floating aquatic vegetation there in the top left. Emergent aquatic plants, these are the typical marsh plants you see in roadside ditches and retention areas and things. Submerged aquatic vegetation, we heard Cassandra mention coontail and the naiad and some of the species that were in the C-43 mesocosm study. And then the periphyte, which we've seen a little bit of discussion about here, which is more of a calcareous algal community that has a real affinity for binding up phosphorus that's in the water that's applied and tying that up in insoluble calcium phosphate compounds. While most of these pictures of these systems, these nice pretty green things with plants and water, and maybe don't look like an engineered system, the reality is that the ones that are designed well and operate the best truly are engineered treatment systems. There's every bit as much of science and engineering fundamentals that go in behind their design as there would be in a conventional wastewater treatment plant or a highway project or a bridge project. So don't let their beauty fool you. There is some actual real science and engineering behind them. I will not go through this in detail and give you a quiz at the end of the presentation. With that said, these have been used across the United States and Florida for about the last 40 to 50 years or so. Some very pioneering work done out of the University of Florida that began in the late 70s, early 80s. Parallel efforts in Michigan looking at the of both cypress swamps in Florida and constructed or natural marshes in Michigan to really accept, in most cases, municipal wastewater effluents, polish those nutrients out of that system, reduce the organic loads that were there, as well as provide some other water quality benefits. They've been studied intensively at the time, both here in the U.S. and across the globe, and has resulted in a number of publications, a few that are listed here, where you can go and look for additional information on these. So why do they work so well? Well, one thing that's really beneficial is that there are a lot of physical, chemical, biological processes that naturally occur in wetlands, whether they are natural wetlands or constructed systems that replicate those functions. Some of those processes are shown here. There are photolytic reactions driven by solar energy inputs that can break up different types of compounds in the water. There's absorption to sediment surfaces, new detrital surfaces, biofilms that cover the plant stems and the bottom of the wetland. There's uptake by the vegetation and the bacterial and microbial populations that live within the wetland. There are biodegradation, transformational type processes that occur as water moves through the wetland. There's hydrolysis, where certain elements are broken apart just by being in the water. Volatilization, where substances that are in the water column are are diffused upwards into the atmosphere and leave the water column to the air. So there's a whole bunch of things going on in there that we can take advantage in looking at water quality improvement projects. Just as a general overview of how wetlands perform for a variety of water quality parameters is summarized here on this slide. These are mostly conventional wastewater type parameters, as well as some that we focus specifically on stormwater projects. Biochemical oxygen demand, that's a measure of the organic matter that's in the waste stream or the water that's being supplied to that system. That can typically get down to about a 2 milligram per liter level. Similar with total suspended solids, whether they're algal-based solids, some other form of solids, or removal in wetlands is typically good for those when they're well vegetated and operated well. The focus here has been on nitrogen and also on phosphorus in South Florida. We see that nitrogen removal in wetlands can get 1 milligram per liter, and I'm going to show you 3 projects where those types of levels have been achieved. The inorganic nitrogen that we've heard quite a bit about already today, the ammonia and the nitrate components, are virtually eliminated in most treatment wetland systems. The natural background concentration for those particular forms of nitrogen is effectively 0. So we can very often, particularly in the summer, when kinetics are maximized at higher water temperatures, get right down to analytical detection limits for the inorganic nitrogen parameters. Phosphorus, the SPAs in South Florida, there's been a vast amount of progress there over the last several decades, really finding out how to get phosphorus removed down to very low outflow concentrations, less than 20 micrograms per liter. Bacteria, pathogens, other things like that can be removed with passage through wetlands. There's all kinds of microorganisms and proteins and zooplankton and things that reside in these wetlands that feed on bacteria and viruses and other pathogens. So there's a whole bunch of removal mechanisms for those. Similarly, there are multiple pathways for removal of heavy metals, organic and synthetic hydrocarbons, and a wide variety of emerging contaminants that are starting to break into the news now. We hear about endocrine disrupting chemicals and personal care products and pharmaceuticals, sucralose, those types of things that come out with the waste that leaves our homes and goes through wastewater treatment processes and isn't completely removed in conventional treatment systems. Some of those parameters are very effectively removed in a polishing type wetland system. We dive in a little more detail into the wetland nitrogen cycle. Again, no quiz on this one either. But what I want to focus on is all the different forms of nitrogen that you see in the diagram in different compartments. There's some in the water column, in the litter layer that's laid down by new decomposing vegetation that grows and then dies, and also in the soil compartment in the bottom. All these forms kind of move around and interchange between the water column and the sediment compartment, and then as you move through the wetland, they change in form. Processes available there that mineralize organic nitrogen to ammonia. There are nitrifying bacteria in there that will take ammonia and convert it to nitrate. And what's really beneficial in wetlands, as you heard Cassandra speak about just before the break, is the denitrification process. Wetlands at their sediment interface are very anaerobic typically. It's a low oxygen environment. There's dissolved organic carbon that's provided by the vegetation in the system. There are biofilms or slimes that are full of microorganisms that cover all the plant stems and the entire bottom of the wetland. And you put those three things together and you get very removal of nitrogen through denitrification, leaving the water column and gassing off to the atmosphere. 3 projects I'm going to highlight now that treat different types of water across the state of Florida, but have all shown a similar ability to get to very low nitrogen levels. First one is the Wilderness Park, which is just east of the city of Orlando in the strangely for Florida named town of Christmas. It's been in operation since 1987, and it treats advanced wastewater from the city of Orlando's Iron Bridge Water Reclamation Facility. It treats a flow of about 16 million gallons a day. It's 1,200 acres in size. And what we're going to focus on here is the inflow and outflow nitrogen concentrations. These are annual averages over its entire period of operational record here. The top line is the wetland inflow concentrations, and the bottom line is the concentration of nitrogen in the water that leaves the wetland and flows into the receiving water body. On the right-hand side there are the averages of those two data sets. So we see that over this long operational history, the inflow nitrogen for this facility has averaged 1.88 milligrams per liter, and the outflow has been well under 1 at 0.87. Again, this is one that treats all municipal advanced treated wastewater. This next project is located in Gainesville. It's called the Sweetwater Wetlands Park. This one treats combined flows of treated municipal wastewater, reclaimed water, as well as watershed runoff, several thousand acre urban watershed. So both those sources of water commingle and come into this project and are treated. Any Gator fans that might be sitting in the audience can look very closely at this picture, and you might see something recognizable there. I'll point it out in great detail. But here's the operational. This project's been up and running since the middle of 2015. So it's a relatively new project compared to Orlando, but the performance for nitrogen has been relatively similar. The inflow concentrations have been a little higher coming in here. This wastewater from this facility isn't treated to as high a level as the Orlando system. There's a little bit more nitrate coming into this system. But as you see, because you've got that denitrification process, it works so well in wetlands, we don't have any problem getting this system down to about that 1 milligram per liter mark for total nitrogen leaving and going to the receiving system. The last project is one that's a little closer to where we are now. This is Freedom Park in Naples, which treats purely runoff. This is not a reclaimed water project or a reclaimed and stormwater combined project. This one's all watershed runoff. It's capturing the water from about a 3,000 acre watershed and treats about 200 million gallons per year of flow and reduces those concentrations in that nitrogen by about 41%. We look at their operational data here. You see that the nitrogen concentrations here are a lot more similar to what we see in the Caloosahatchee River, the Three Canal, kind of averaging there around 1.5 milligrams per liter, which is kind of in the range of what the inflow concentrations were like in the mesocosm project that Cassandra spoke about. And we see that this treatment wetland system is similarly capable of getting those nitrogen concentrations down below a milligram per liter. So again, this is because all the inorganic nitrogen basically is being removed, and those little bits of available organic nitrogen that are being produced in the system, as Cassandra showed, are also being consumed and reduced. As part of our earlier work in this particular some previous projects for the water management, we looked at performance from a range of systems across the state, evaluated those data based on vegetation type and soil type, and started to see if there were any differences there. And what was interesting for nitrogen, and this was borne out again in the mesocosm project that we just heard about, was that there wasn't a very clear difference in performance across vegetation type for total nitrogen. The same is not true for phosphorus. The submerged aquatic plant periphyton community showed a much better removal efficiency for phosphorus as a function of vegetation type. So there's some differences there depending on what parameters you're really interested in improving. However, when we look at it based on sediment type, we found some very interesting differences relative to total nitrogen removal. We grouped these based on the natural substrates that were there for those treatment wetland systems, whether they were clay, peaty organic soils, sand, or lime rock. And what we found was that the sandy mineral soils consistently produced the lowest nitrogen concentrations. That is why this kind of spiraled into the work that Cassandra talked about, why the soils that were put into those mesocosm tanks were sandy soils from that site, and why we went to the next step of then looking at any labile nutrients that were there and doing the acid and peroxide rinses to liberate those and free them and be able to really compare that difference. But kind of across the board, and this is consistent with the Freedom Park project, the Orlando project, and to some degree the Sweetwater project, is that they're all constructed on mineral soils. So finally, some keys to maximizing wetland performance. Again, this kind of goes back to this concept that you've got this nice pretty green blob thing with plants growing in it, and wow, it looks great. They can be designed well and they can be designed small. So it's very important to understand the system goals. There are differences in how you approach a design and how you approach operation, whether you're concerned with load reduction or concentration minimization. There are big differences between the STAs that are south of Lake Okeechobee that are trying to minimize the outflow phosphorus concentration versus the couple of STAs that have been constructed on tributary inflows to Lake Okeechobee, such as the Taylor Creek STA, that is focused on load reduction. They operate at different efficiencies and they operate with somewhat different purposes. So it's important to understand at the outset of a project, what's the goal, so that you can approach the design in the right way. As we just saw on the previous slide, selecting the right site. The soils matter. If you want to go and absolutely minimize nitrogen concentrations, probably don't go build an STA or another type of treatment wetland system on a peaty organic field. Choose a better place for it. Maximizing hydraulic efficiency. This is that whole green blob thing. You can have something that looks like it's unorganized and maybe just this green space, but if you really want to maximize the water quality performance benefits out of that area, the grading design is important. The location of inlet and outlet structures, the internal flow redistribution is important. How it's analyzed, how the cell geometry is laid, and how that relates to velocity and depth control and a whole variety of other issues. So there are right ways to do this, and there are certainly much less right ways to do this. If your goal is maximizing water quality performance. Habitat restoration, those types of goals can be accomplished through a whole variety of different approaches. And then upstream flow equalization can be important. We saw with the previous project, I'm going to mispronounce it if I try to say it. Thank you. The use of a flow equalization basin, the use of a reservoir and an STA compartment in the C-44 basin, the use of a reservoir and the STAs in the EAA basins. Flow equalization or reservoir storage prior to a treatment wetland system allows you to really dampen some of those inflow peaks that you see. You get seasonal changes in nitrogen and phosphorus concentrations coming in, differences in flow, all of those get dampened as it goes into the storage basin, and then you can release that back out at a much controlled, more consistent level into the wetland and get better control over the operational characteristics of the system, as well as much more predictable outflow water quality. And with that, I'll turn it over to you.
During my presentation, I will be using the cursor to point at certain locations on the slide. So if I start talking about a specific location, look for the cursor. Lehigh Acres Municipal Services Improvement District was created as East County Water Control District in 1958. In 2015, we were converted to Lehigh Acres MSID and had the ability to pick up other powers, but we're still primarily a drainage district only. Yeah. Get rid of that first, right?
Yeah. All right.
All right, there we go.
Yeah.
All right, I'm doing a politically correct thing and pay homage to my board real quick. You're gone. This is a map that was created by Kevin Irwin and about 10 years ago, but it outlines what our drainage basins used to look like prior to development. This is the Orange River Basin in this area. Hickey's Creek Basin went way up into Hendry County, as well as Bedman Creek area. But with the development of agriculture and the development of Lehigh Acres, everything inside of our borders flowed north, and they also got quite a bit smaller. And we've seen this picture today where the project area is. You can see our project area that we're going to look at today is about in the center, and that's area. This is our district. It's 110 square miles. It has 311 miles of canals, 20 lakes, culvert crossings. We have quite a few weather stations, 31 weather stations. We have 109 water control structures, and 64 of them are automated, so we can control where our water goes pretty good. Current projects, just finished this weir out on Henry Canal, which is real close to the C-43 Reservoir. This weir was destroyed during Hurricane Irma. In rebuilding it, using money from the NRCS, canal 1,000 feet upstream to make way for a new project. The Absorb project we finished in 2018, that added 25 water control structures in southwest Lehigh Acres, being able to raise water levels, hold back, isolate water from the Caloosahatchee up to 3 or 4 feet in 10 square mile area. There's some pictures of construction. West Marsh and Harns Marsh and West Marsh. Harns Marsh is a 587 acre marsh that the district we built in 1992. West Marsh is a parcel that's 105 acres that was purchased by Lee County 2020, just about 8 years ago. They have allowed us to use that for a stormwater treatment area. This is this picture is looking northeast. The West Marsh area is here, and our original Harns Marsh is over in that area. This is the picture of Harns Marsh, 587 acres, been there a long time. A lot of people do like to bird watch in that area as well. The West Marsh is over here to the west. This is the conceptual plan that was drawn by AIM Engineering, and we are about halfway through the excavation of this project. So there'll be some deep lakes. We're restoring. We're leaving the wetlands actually in place and creating filter marshes throughout the rest of the project. All of this dirt is being moved down to State Road 82 widening project. Crest, I just mentioned before that we moved a structure 1,000 feet south. The structure was moved down here by this Crest project, this little square right here. That's a 205 acre parcel that we have purchased recently. That's a picture from a drone. This is the conceptual plan right now from our engineers. We'll bring water in off Henry Canal to deep lake storage through a filter marsh, and then into deep lake storage again, and it'll outfall back into the Henry Canal. That will be a treatment process that will be going on all summer long until we get a heavy event. We'll be pulling water in a heavy event out of Dog Canal, which is a half mile away from our Henry Canal, filling up our storage and then conveying water from Dog Canal to Henry Canal to help some flooding issues that we also have in big events. Henry County widening. We're widening 3.5 miles of our canal from 80 feet wide to approximately 200 feet wide. All of that dirt is being taken down to the State Road 82 widening project. So DOT basically has built the West Marsh and are building this at no cost to us. They're discharging their water from State Road 82 into our system. We worked out an agreement on that, so that worked out well for everybody. Both sides save money. This is just an early picture of the widening process. Between the two projects, they're taking about 100,000 dump truck loads from our projects to State Road 82 widening. That brings us to why we're really here. Options for the quality treatment on the C-43 Reservoir. We have some options here. We have the GS10 project that I'll get into, the Carlos Waterway that we own. Dog Canal and Bedman Creek are all treatment options that could be used by the Water Management District. And of course, the benefits that we've been talking about with all the other projects, reduces freshwater imbalance, reduces nutrient loading. That also gives public-owned lands some storage, some ability for recreation. The GS10, this is another project that we worked with Lee County. They purchased an entire section of land within our district. We nominated the parcel to 2020 program, and then over a couple of years, things were worked out, and just a month or two ago, Lee County did purchase the project, and out of the 627 acres, about 560 we're going to use for water quality water storage project. You get the same benefits basically here. You get the extra storage, the water quality, flood control, you get wildlife and recreational enhancements as well. This is that our staff drew, but these numbers that we had back a couple of years ago, and I think they're probably still pretty much the same. The top of the berm for C-43 Reservoir is going to be at 57 foot above sea level, where natural ground's at 19.2. So then you're going to have, when the reservoir is full, it'll be 42 feet above sea level. You could discharge this water into our canal, and our next structure, it could all pretty much gravity flow. Our next structure is at 16.4, and then it gets over into section 10, where we pump it up into section 10, get all those benefits that we were talking about, and then you've got gravity flow down into Greenbrier Swamp, which is another 500-acre swamp that we own that would work really well for water quality, into the Hickey's Creek Basin, and then into the Caloosahatchee. This is a map generally of where things are located. You got the C-43 Reservoir. There is a Townsend Canal that's been talked about, mentioned today. 100 feet west of the Townsend is our Hendry Canal, so we're that close to this system. Water, pretty much like I said, could gravity flow either across King Canal or Easy Canal to section 10. We would have that water quality water storage project here. It would then filter up through our Greenbrier Preserve and discharge out of the Greenbrier Preserve into the headwaters of Hickey's Creek, or down our canal swale over to Hickey's Creek Canal and back out. This project, has a lot of merit, and I know it's going to need a lot more study to make sure that it's going to work well for everybody. But the beauty of it is we're going to be using this system all summer long in the rainy season, and in the dry season when the C-43 needs it, we won't be using it, so they could basically take control of that system. This is an aerial of section 10. It's an old mining pit. They used most of this. This is mostly a lime rock pit that they used to build the roads in Lehigh Acres many years ago. So it's partially excavated, so it'll make it a little easier for us to manage. This is the section 10 concept map. We're about to go into design. We're going back to the legislature again this year to try to get design. It's going to be it's going to be a $750,000 design. But the idea with the project is we'd have a pump station down in the lower right part of section 10, again into deep water that would flow through filter marshes into deep water and get the extra storage, extra water quality in the deep water, north out of the section 10 property on into Greenbrier that I showed you before. This is also going to have a public park area. It would have, according to because they're going to manage the recreational portion, but they should be beaches and fishing and all kinds of recreation there as well. This slide shows you between this project and another project all the different directions water could flow from C-43 into our system. The next one I'm going to talk about, since we've pretty much finished up with section 10, is our Carlos waterway that's already existing, already has a discharging point to the Caloosahatchee River. The same type of a drawing. We got, again, the water levels up to 42 feet elevation there in the reservoir when it's full. We've got 5 structures in Carlos waterway, and everything can just gravity flow down into the Caloosahatchee. Now, in between these structures, which are sheet pile, sharp pressed weir structures, right now it's just a 350 foot wide grassy swale, but that could be modified to, to make those into some kind of a filter marsh system that would provide more water quality. This is an aerial. So here again, you've got the C-43 reservoir border right through here. You got Townsend Canal that you've seen that flows out to the coast. 100 feet from the Townsend Canal is Henry Canal, and Henry Canal flows into the Carlos Waterway, and these symbols are water control structures or weirs leading to the river. And again, we're not using that system. We stopped discharging into that system probably in September, October. From that point all the way up to the following June, we're not using the system. So due to its location and the operation schedule of the Carlos Waterway, I think it should be studied and be a very interesting option for some of the water from the reservoir. It's certainly not going to solve the whole issue. But between the two projects, we've quoted Roger Kopp, who a lot of us know in the room. He thought that between the two projects, we could potentially handle half of the discharge from C-43. That certainly will have to come out in a study. We haven't got any hard data on that. Again, my name is David Lindsay, and that finishes my presentation. And I guess I'll sit down and we'll answer some of your questions as you submit them.
All right, our final Q&A of the day. For those of you online, if you've recently joined us, if you'd go to menti.com, www.menti.com, and use the code 143919, you can now submit your question, and they will be shown live with the questions that are being submitted in the room. So we'll just take a moment here and let these filter in, and just feel free, panelists, to respond to any that you're ready to respond to.
I don't have a general contractor's license. Well, we have to define the technology first that creates the estimate of what the nitrogen removal is going to be.
Oh. No, it's dying.
Well, I can take that Bob question to a certain extent. In Lehigh Acres, we did it. We built a model of our. I think there is a button. There you go.
Yeah.
Good now?
No, when you talk, it should turn green.
Okay, there we go. We had a complete computer model renovated since 2000, and it was estimated that at full growth, when we get Lehigh Acres is fully grown out, the population could be 325,000 people. There's 127,000 parcels in Lehigh Acres. We built out the homes and the commercial through a 100-year storm on top of our district, and they concluded that we're 15,000 acre-feet short of storage in our system for that situation. So since that day, we've been working on the growth, and we're about there as far as picking up that storage that we needed. We're close to the 7,500 acre-foot mark at this point in time.
I'll tackle this one with my name in it about how the projects I spoke about are funded. Most of the project, the Orlando project and the Gainesville project, are municipal government projects. They're funded through the water and wastewater ratepayers for the most part. So that's worked into their utility bill. I don't know specifically about the Orlando project, but in the case of the Sweetwater project in Gainesville, there are also a variety of state grants used to partially fund that project. There was money from WC for some of the habitat and public access components. Section 319 funds from DEP were also used to help offset the cost to the city of Gainesville ratepayers.
So somebody had asked about the Section 10 mining pit. It was a mining pit that was mined. They mined lime rock out of that to build roads. So there's still a large percentage of lime rock in what's remaining there on site.
Question on nutrient removal efficiency as a function of treatment size, that efficiency is really related to the hydraulic loading rate than it is the size. So for the same volume of water that may be applied to a wetland, as the size increases, you can theoretically achieve lower and lower outflow concentrations. So the concentration reduction efficiency would increase as area increases at the same flow rate. For hybrid wetland systems, coagulants and flocks are used. There's been some work looking at alum as an amendment to those systems. Ferric chloride has been used in some cases, but alum is really the chemical of choice in those types.
Okay, we have time for about one more question, and then we'll need to wrap up. Any last question that you see there?
Not it. Water quality in wet detention ponds, not entirely sure what the question is. There is.
Can I ask a question?
Sure.
Which may be simple. I have several questions they haven't gotten to yet. We have thousands of wet detention ponds in Southwest Florida. You can get cheap filtered, and they also serve to be treated. They're supposed to serve water quality treatment. Yet nobody's talked about that all. My concern in dealing with these ponds, both as a county employee in the past, but as now a consultant and biologist, is that typically they get out of balance. They start out as a mineral systems you say function so well, but then we go and we allow people to spray all the plants and dose them with copper sulfate.
Right.
That's what I was getting at.
Okay. Well, you nailed it. You kind of answered your own question in that they can start off well-intended and functional, and some may maintain those functions over the course of time, and some may degrade functionality as a result of particular management issues. As a comparison to wetlands on an acre-for-acre basis, because of the variety of processes that are there in wetlands that are somewhat less available in wet detention ponds, wetlands can typically provide a higher level of treatment per unit area than a wet detention pond.
All right, well, with that, thank you very much. And if you're able to stick around, I'm sure that they'd be happy to answer additional questions. I'll just say, as far as stormwater detention goes, I know that studies years ago when we were working on statewide stormwater regulation that they typically get between around 40% nitrogen removal, 70% phosphorus removal. So there definitely are some things that can be done to create a more treatment-trained approach to get higher removal efficiencies, something to think about. Okay, so now we're going to go into our final session. If you guys are ready, then we're going to move on. Okay, so your ideas, we're going to cover this really quickly. Again, this is the interactive closing. We want to get all your ideas mailed. These, again, are going to be provided to the consultants. And the people online, you're welcome to join in and participate, Menti.com, using the code 143919, and it will be at the top of each slide. So what words come to mind after today's summit? What did you learn? What's like something that immediately pops to your head that you got out of today? Or how did you feel about the summit? Just anything you want to put down. If you would just enter that really quickly, we'll gather up your input. Oh, I like the first two. We got optimism, progress. Energized, engaged, productive. Give you another minute or so to respond. All right, it'll keep gathering those up as we move on, but very much appreciate you taking time to throw some ideas out there as to how you felt about the summit. All right. Which area are you most interested in learning more about? So we have 4 different ideas here. If you could go ahead and check the one you think you are most interested in learning more about, so we can kind of prioritize our efforts moving forward. We have harmful algae blooms, natural water quality treatment options, Caloosahatchee water quality projects, and Caloosahatchee water quality conditions. All right. Looks like natural water quality treatment options was favored out of those choices. Next one, which treatment option do you think is most important to pursue? So this is a slight variation. We have new natural water quality treatments and several others, but they just disappeared. So you'll see them all on your screen. Go ahead and put the one that you think is the most important to pursue. All right, 28 responses. Great. Climbing. So we're going to continue to let those roll in, and we'll make sure to capture and download all of these and provide these. All right, now it's stuck. Then open-ended question. Submit what your ideas are about C-43 reservoir water quality treatment after hearing everything you've heard today. Or maybe something you haven't heard today that you feel should be considered. If you could just go ahead and enter your idea now, we'd like to collect up all of your ideas. And don't be afraid to put something down that you heard that you liked, so that you can make sure that that was considered if you heard something today that you want to continue to be explored. All right, we have 27 responses to that, so we are going to continue to capture those as we move on. How do you feel overall about today's session? Pick an emoji. Hey, we're doing pretty good. No boring or no buenos yet, so. Oh, good. Okay. So with that, we're going to turn back to just a couple closing comments for today. While we're doing that, I just want to first say that there is no way today could have happened without the fabulous staff at the Coastal and Heartland National Estuary Partnership. The whole team pulled together to pull this off, so please join me in congratulating them. All right, so getting involved. This is an ongoing effort. I think you heard earlier at the beginning of the day, for those of you who are with us, that there is going to be a feasibility study kicking off shortly. We've had the consultants here with us today, thankfully. You'll be hearing more about that. We will also be trying to post the recordings of today's sessions online. So if you go to chnep.org, our page, you should be able to find a link. We right now have a page up about this. We're going to update it with the recordings, with any information that we've gathered from today and photos and things of that nature. So feel free to go in a day or two, give us a day or two to upload all that, but we should have that available for you. Also, if you want to learn more about your waters, we actually spend a lot of money every year to gather all the water quality data that's being collected and that is publicly accessible to us in one central place right now called the Charlotte Harbor Water Atlas. This atlas is your go-to spot. It has an interactive mapper. You can zoom around, click on water bodies, see all the different measurements, flow, water quality data, water quality trends tests, different things to look at with regards to exploring and learning about the conditions of your waterways. Also, we encourage you to think about following us on Facebook if you're a social media person. We have a HNEP Facebook page. It's a great way to keep in touch with different events that we're hosting all through the year. We have monthly volunteer events. We have outreach events. There's just a myriad of ways that you can get involved. We do a lot of citizen scientists with volunteers. We've actually been planting seagrasses in the Caloosahatchee, oysters in the Peace River. So some of you I see who are here, Caloosa water keepers and water rangers have been helping us on some of these projects and have directly, thank you very much for being here, helped us in planting. So there's just an open-ended invitation for anyone online or in the room who would like to join us in trying to protect and restore these resources. And last but not least, thank you to all of our summit presenters, to Lee County, Sanibel Captiva Conservation Foundation, Conservancy of Southwest Florida, Florida Gulf Coast University, South Florida Water Management District, Lehigh Acres, Florida Department of Environmental Protection, City of Sanibel, U.S. Army Corps of Engineers, Wetland Solutions, North Carolina State University, and finally to ourselves. And thank you very much for taking the time to be here. Very much appreciate it. That we're adjourned. Thank you guys online.